Okay, all right, guys. So thanks a lot for coming over. And I would, as Srikanth mentioned, right, we've been associated with NanoCell for a very, very long time now. The stage, I feel, has been perfectly set by Sitaraman. He spoke about a lot of reasons why testing happens, not just with the traditional TCP UDP traffic, but supposed to introduce a lot more of applications into the real testing as well. So Spirent as a company, we are also into testing and measurement, right? We provide testing solutions across a wide portfolio of multiple different technologies. So I have the next 10 minutes to give you a glimpse of different solutions what we have to offer, including Wi-Fi as well. But then we will not restrict ourselves just for Wi-Fi. This is a little bit about the company. One major point to highlight here is that a majority of chunk of business that we actually make gets back into the R&D, on 20%. And so, we are one of the developers of the latest technologies that's currently being evolving as well, right? And a majority of, I would say, all of the NEMs, all of the operators, all of the SIs, for example, use our solutions into multiple different form factors, right? And then we play into multiple different domains and multiple different technologies, not just with Wi-Fi as such, which means that the entire testing measurements gets elevated when you start looking at different offerings that Spirent currently has to offer, right? So we have been doing a lot of testing off late with 5G, in the initial stage of discussions on 6G as well, along with V2X, all the different applications what we actually spoke since morning. We have kind of being a partner with multiple different customers for being able to test those different technology as well, right? So if you have noticed the title of the presentation, it talks about digital twin and the networks, right? So in the past, there used to be a time where we were mainly focusing on testing the networks, be it a lab network or a live network, etc., right? So now we're trying to do is that in the era of AI, for example, people are trying to see what is the best possible fashion to be able to get the entire network within the lab itself. When we talk about the network, it looks a lot more different, than the traditional, 3 blocks where you have clients, you have the access network, and then you have the data center or the packet core networks here. So what is the case for digital twin? It is very, very impossible. It's almost impossible to be able to replicate a live network within the lab itself, as it is very, very limited. Imagine, we're doing a latest testing into a V2X kind of environment, and we are looking at hundreds and millions of driving conditions and driving patterns that is needed to be able to train a respective model, that analyzes the traffic conditions, for example. That is almost impossible, to be able to get that amount of data sets into the live network, right? The best thing is that why don't we get that into the lab itself? The next thing is that the environment where you have a lot of this Wi-Fi being deployed, 5G being deployed, for example, are all going beyond telecom. The days of being able to browse data on your phone, etc., is gone for 3G and 4G. Now we're looking at taking technology back, from the respective users into multiple different domains as well, like manufacturing, for example, hospital and mining and stuff like that, right? So they're all critical applications. So latency plays a very important role there as well, right? Plus, we spoke about where do you localize the data? Is it going to be on, a hybrid architecture or a cloud or an edge, for example? The main concern is because of not just the latency and then the bandwidth, but also security as well, which plays a very, very important role. Now, digital twin is one such concept that's going to get you a kind of solve you all these respective issues, what we saw, into a luxury of a lab itself. In the sense, we will be able to completely control the entire network itself, have it deployed, and then be able to run them. Once it's all running in a controlled environment, you'll be hassle-free and don't worry about the security as such, right? Plus, it is a lot more cost efficient compared with what you typically get from the real world as well, right? And then the network as such would look like what you see on the top there. It has a bunch of clients, and they're all talking to an access network, and then getting you back into the internet or the PDN, for example, right? Now, what we added there is that the entire network, it's pretty easy to get multiple such devices, have them connected. But then, as a company itself, what we generally do is that every single tool that we provide into every single block of devices there is able to emulate the traffic conditions, is able to generate real-world applications, so that you can actually test. Plus, the tool itself comes with loaded thousands and thousands of test cases that you'll be able to automate them end-to-end, which means that having a single dashboard of control, you will be able to mimic, say, for example, a bunch of Wi-Fi clients. performing multiple different transactions like trying to download a video file, doing a WhatsApp call, for example. And then you also have that collaborated along with the 5G clients as well, and then a 4G clients, for example, trying to do a, access into the 5G along with the Wi-Fi, for example, right? And then using the solutions for automating the entire platform itself, you'll be able to run the number of test cases that you can actually imagine. That's not been possible within the live network itself. So this is our solutions for Wi-Fi. In the respective architecture, what you actually saw, we did see a section for UEs, which spoke about Wi-Fi UEs, which spoke about 5G UEs, for example. So this is a chamber-based solution. This does almost all that we spoke about today: EMLSR, MLOs testing, for example, being able to generate live traffic conditions along with AP simulations and AP testing, etc. All that we spoke today. We can actually talk a lot more about the capabilities and features once you visit our booth. But yeah, the tool supports all of those conditions. Now I want to take you into a different direction as to understand testing just an AP. Is that actually sufficient? Or do we have to go beyond what we perceive today as an AP testing? The moment we talk about Wi-Fi, everybody narrows down and focuses only on the AP testing as such. So trying to build a case for digital twin here, I'm trying to tell you, just give you two examples. Imagine there is a home G node B or a home E node B, that supports both Wi-Fi and also the cellular connection as well. How do you actually go back and then test the cellular offloading technologies, right, or coexistence, for example, along with Wi-Fi? So one way is that you obviously go back and then have a licensed band, have a base station simulated, or base station actually being deployed, plus a real PDN, etc. Or you probably have to be able to understand that, can I replace those real devices with simulated devices? Having a real core network against a simulated core network, having a real base station against a simulated base station, right? That's how the topology would typically look like. So build an architecture here. So what it looks like is that if you are able to utilize Octoscope as a solution that simulates a lot of Wi-Fi clients, Wi-Fi 6, 6E, 7, for example, at scale, and with real applications. After that, to be able to mimic a real-world conditions, you bring in a channel fader there. The channel fader provides you a multiple different channel models where you're able to actually replicate those realistic conditions within the luxury of your lab. And then, when you talk towards the packet core, when you talk towards, because we're speaking about the 5G here. 5G depends on the packet core before it hits the PDN or the internet, right? So in that particular case, you can either go back and then use a simulated packet core there and then be able to test it as well. Now in this particular case, you have the AP or the base station being real nodes there. What if you have to subject only for the AP for testing along with both the left side of the network, that's the clients, and the right side of the network as well? There what we can actually do is that go back and then replace the base station with a base station simulator there, which means that you're actually trying to build the network and then subjecting the access point under the test block by block by mimicking the real world conditions that you typically see in the real world. Not just testing the AP with like a feedback mechanism, right? So the next thing is that, okay, so in the previous slide, what I forgot to mention is that all of these happens when you have multiple different solutions there being simulated and being connected there. You also see they're all being managed using a single dashboard there. Although I'm showing you a bunch of hardware devices there, all these devices can also be virtualized as well, except for the ones that actually radiate. Everything else, for example, a packet core, a simulator, etc., they can all be simulated via software or containers, etc. The next example can be something like this. If you're able to test a fixed wireless access testing, like an outdoor unit, for example, you can have the connections from a G node B feed or a G node B feed, for example, and then have it terminated on the real devices along with our simulators for E node B, G node B as well, right? The third example is, it's not just about testing on the radio. A lot of support has to be also given on the Wi-Fi access points or a G node B, E node B, for example, from the backend as well, from the packet core as well, right? If you look at the standards from specifications by 3GPP, for example, a lot of new nodes have been introduced these days. And for example, one of them here is called N3IWF, or a non-3GPP interworking function, network function. That's been introduced in release 16 phase 2. What it speaks about is that it kind of gives you a mechanism where an untrusted network like Wi-Fi can actually be onboarded onto a cellular network as well. One good example can be V2X. If you use a short-range communication within V2X, vehicles and vehicles can actually talk to each other. Whereas if you want to talk to satellite communications, for example, or a grid, for example, you also need a cellular connectivity as well. It's called CV2X, for example. In such kind of scenarios, you need assistance from the network perspective as well, right? Along with that, being able to test those network functions at the core level. The network functions also utilize multiple different protocols here. There's IPsec, for example. So all of these are an essential candidate for testing as well. Extending this further, we also see 2 more nodes being added on the Wi-Fi network as well. That actually helps you the convergence between the Wi-Fi and then the 5G as well, going forward. So for example, testing of TNGF or a TWIF, for example, along with the UPF also plays a loss of precedence. We did speak about QoS and quality of service, for example, in the previous presentations. But then all of those are being governed, monitored by the packet core network. It can be a PCRF, it can be a PCF, for example, in a 4G or a 5G network, right? So ultimately, what is all this leading towards? Imagine if you take a big step back and then see, the way this solution has been built up. You have multiple different devices that are able to simulate clients or a packet core and stuff like that. Ultimately, all of these particular devices, right, where they have, when you come back and tell me, back in the 4G days, customers used to ask us, what about those test cases there? We used to say, look, we're going to give you a basic framework. You go back and then build as many test cases as you require. But today what we do is, we're also giving you with thousands of test cases that you will typically be able to utilize out of the box. So going forward, there was a previous panel discussion where we spoke about how relevant is it, how relevant is the moat to our respective company having a history of all the data. Well, today what happens is that with the tools like this or a digital twin platform, you don't need to go back and then have a history of data because they may not be relevant into a previous technology. It does not make sense for me to have a lot of information from a 3G network or a 2G network or a 4G network, right? What I need today is the kind of data patterns that you see, the kind of call models that you actually notice in 5G network, for example. That is where a digital twin network like what I'm proposing here, along with AI, goes a very, very big role. Because ultimately, the goal is to have self-optimizing, self-healing, self-repairing network, right? So you don't need to have any prompts to be provided. It should automatically be able to handle the entire network itself. That's the eventual goal that we're trying to head towards, which means that it leaves humans to be able to perform just the governance of the network itself. So having a digital twin platform that caters to multiple different segments of a telecom network within a luxury of your lab, goes a long way in being able to test not just the Wi-Fi access points or Wi-Fi technologies, but also supporting technology around the entire Wi-Fi as well, right? So that was my last slide. Was in time? Thank you.